Hi, this is Mr. Bourne, your math teacher from Minnesota, and this is a video that will show you how to graph and find the area underneath a normal density function. Here's what you're going to learn: how to graph the normal density curve and how to find the area under a bounded region, a lower and an upper. Now this is one of a three-part series. Part 2 is creating a function where you can instantly find out z-scores, and Part 3 is more advanced functions for distributions using the calculator. Very cool. I hope you see all three parts. The links will be at the end of this video. Okay, now you will need a TI-nspire CX CAS or a TI-nspire CX, or even the older TI-nspires, the ones that don't have any color. Those work just fine. Now before you begin, you should check to make sure that your calculator has the current version of software. Anything above version 3.6 will be just fine. You can check this on your own calculator by pressing the Home On key, followed by pressing number 5 and then number 4. And you'll see a screen that's similar to this, and you can find out the version on your own calculator. Again, 3.6 or greater. Now, the normal density curve is a function. It's one-to-one and onto, and in order to graph it, you can use this equation. This may or may not be in your textbook, but yeah, it's pretty long and complicated. The Greek symbol mu is the mean, and the lowercase Greek symbol sigma is the standard deviation. For the purpose of what we're doing, this will be a 0 and a 1. You don't have to put in that long equation. You can if you want. It'll graph just fine. Here you're seeing a screenshot that if you put in that monstrously long equation, it will graph the normal density function just fine. But the TI-nspire calculators have a built-in function which kind of takes care of all that for you, and it's called norm PDF, and that's short for normal probability density function. Okay, turn on your calculator, and by pressing number 1 or using the directional arrow keys on your keypad, choose number 1, New Document, and press Enter. And you are going to choose number 2, Graphs. This is going to be a graph after all. All right, now at the top of your screen, here is the space for function number 1, and this is where you enter the function norm PDF. You can find this function pretty quick by pressing the key on your keypad, which is on the right side, and it has a picture of a little open book. This will allow you to access the library. So one press of that, and you see an alphabetical list of all of your functions. Skip over to the next tab there, or press number 2, and this breaks down the functions by group. So use the downward key and look for, there it is, probability. Press Enter. Down a little bit, and we're looking for distributions. Press Enter, and it's the first one on the list. Normal PDF. Now, if you have the wizards on checkmarked, it will prompt you for an X value. Go ahead and put in X, because we're going to be graphing. And you can keep this as 0 and standard deviation as 1. Continue to press the Tab key to advance it, and then press Enter when the OK button has that box around it. Okay, so here's your graph. Not very remarkable looking, and it doesn't exactly look like the normal curve, does it? It's just a nice little bump. All right, well, a quick way to adjust your screen in order to see it is to press the menu key, and then press number 4, Window Zoom. All right, you're going to go down here past number 9 and choose selection A, Zoom Fit, and press Enter. What the calculator does here is it adjusts the window so that the highest Y value is just below the top lip of the screen, and the lowest Y value is a little bit above the lower lip of the screen. But it looks skinny and still not quite perfect. Okay, here's what you do in order to make it look like a normal density curve. What you're going to do is change the -10, which is on the left side, to a -3.5, and you're going to change the +10 on the right side to +3.5. You can do this by using your finger and brushing it on the touchpad to bring the cursor over the number that you want to change until you see where it says text. Double tap on the center of the button of the touchpad, and now you can change the value. Put in -3.5 and then hit enter on your keypad. Repeat the same process by using your finger and brushing it over on the touchpad. Double tap on the 10 and change that to 3.5. Okay, now we've got a nice looking graph. Okay, now you'll notice that on your graph the calculator has nicely overlaid a label of what the function is, and sometimes that can get in the way of some of the math that you want to see. Now if you want to move it, just use the touchpad to move the cursor over until it looks like an open hand and has the word label next to it, and then by pressing the Control key followed by the center button of the touchpad, you can move it up higher till it's out of the way. Alternatively, if you want to get rid of it altogether, just put your mouse over it, your cursor over it, and then Control Menu, and you'll get this context-sensitive menu and choose number 2, Hide. And you still got the graph, but you no longer have that pesky label in the way. Okay, now let's use that nice graph to find the area under a lower bound and an upper bound on the curve. Now, the total area underneath the entire curve is equal to 1, but let's say we wanted to find the area from 1 standard deviation all the way up to as far as we can go, like to infinity. So we want the area under just this portion right here. How can we do that on the calculator? Like this. Pressing the menu key, we're going to analyze graph. So choose number 6, and we're going to go down to integral. Don't worry if you haven't had calculus yet. Integral will find the area underneath a curve. Alright, now it's going to prompt you for a lower bound. Now using your finger on the touchpad, you can manually position it, but we want to be exact here, so you can also key in a lower bound where you want. So using the numbers keypad, type in 1 and then hit enter. And if you have if you're going here on the other side here, it'll ask for a lower bound again, but we want it to be an upper bound. And if we do it just to 3.5, we're not going to get as an accurate an answer as we need. So we're going to again type in an upper bound, and let's choose, we can't put in infinity, but we can put in a big enough number, so let's choose 5. Alright, now once you choose number 5, it will reposition the window coordinates so that we see a little bit more of the graph both on positive and negative x-axis here. You can use your cursor here to position it over this number right here. That is the area, and we can move that over here so it's a little bit easier to see. And but that's only 3 digits of accuracy. Suppose you need 4 digits. In order to see 4 digits of accuracy, move your mouse pointer over the text and press Control Menu, and then choose option number 2, Attributes. The very first top box here, we see Custom Precision. You can use the left-right arrow keys to increase it to 4, and then press Enter, and there we go. There's the area from 1 standard deviation on up, 0.1587. Let's see if that's correct. Okay, what you're seeing is a standard Z table, and this tells us the area from a Z score all the way down. So let's find the value for 1 standard deviation. There we go, right there in the red box, 0.8413, and by doing a little bit of subtraction, 1 minus 0.8413 is indeed equal to 0.1587. Okay, that's it for part 1. Thank you for watching. If you want to see part 2, the z-score function, really useful, and part 3, advanced functions for distributions, just click on the link right here in the video. Thank you.